What's up, everyone? It's Mr. Marambo coming at you with more science. In our last video, we talked about the basics of how to run an experiment. Today, we will cover our unit talking about energy transfer and transformation, which includes some items and knowledge from our electricity unit. Two things on the schedule for today. First, we'll review the different laws applicable to energy transformation and transfer, which include the law of conservation of energy and the law of conservation of matter. Second, we will review the concepts of energy transfer and transformation. So the law of conservation of matter and the law of conservation of energy are two separate laws or theories that scientists use to explain the world around us. Now, the key word here is conservation, which means to save. So when we're talking about the law of conservation of matter, we're saying that matter, solid, liquid, and gas phases of any substance, any element, cannot be created nor destroyed. It is conserved as it passes through things. So matter is conserved when it transforms and also when it transfers between locations. The same goes with energy. Energy is also not created nor destroyed. So whenever energy is transferred or transformed, none of that energy is lost, nor is energy ever created. Based on these laws scientists use, that means everything around us, the matter, the clothes that you wear, from the food that you drink and eat, all of that has always existed. And so has the energy going all around us. So here I have orange juice. It is a type of matter. It is a liquid that I can consume. When I do drink it, is this liquid therefore destroyed because I ingest it and I digest it? No, this matter is actually transformed into another form of matter inside my stomach in the form of chemical matter that can be used as energy later. So matter cannot be created nor destroyed, even though it disappears. Say also, for example, this is the process of denitrification. So this is nitrate, NO3. If it then converts into oxygen and nitrous oxide, does it lose any of its matter? We can actually see here in this chemical equation that this NO3 equals this O2 plus NO. There are one element of nitrogen here and 3 elements or atoms of oxygen here, and the same on the other side of the equation. So matter, even though it's transformed into something else, it always stays the same. It is not created nor it is destroyed. It simply transforms and transfers just like energy. So when talking about energy transfers and transformations, I'm going to use my phone as an example. My phone has a lot of electrical energy in it. There are various forms of energy, but we need to know the definitions of those forms. Electrical energy is electricity, and my phone has been charged with that energy. When I use my phone a lot, it starts heating up. That is thermal energy. It also has some light on it as well, and this light energy, or this light, is also called light energy. So we know that a battery is chemical energy, but this chemical energy is transforming when I turn it on into those 3 types of energy. It is transforming into light energy, it is transforming into, let's say, thermal energy, and lastly, we should know that whenever electricity is present, it creates 2 different types of energies, and this is included with your phone as well. We already named one of them. It's thermal energy. Some heat is coming off of this in the form of radiation. But also, we should know that there's a magnetic field whenever energy is present. Just look at that. I have a magnet right here. Boom, sticks right on the phone. Whenever electricity is passing through a circuit in a closed circuit, it creates a magnetic field and it releases thermal energy, which means that whenever electricity is present, thermal energy and magnetic energy is present as well. So you look at my phone hang. We also have the transfer of energy other than transformation. So this is at potential energy. This magnet has the potential to do something. And I can simply transfer that potential energy, or excuse me, I can transform that potential energy into kinetic energy, but then I'm transferring that kinetic energy from this hand to the other hand. Also, keep in mind that food is chemical energy. It is chemical energy that we ingest in order for us to survive. So when we do mechanically digest food, that is chemical energy being transformed into us or transferred into us. Lastly, when talking about energy transfer, when it comes to heat, we should know that that thermal energy always goes from that of the higher temperature to the lower temperature. Temperature is another way of saying average kinetic energy, which is the kinetic energy of the particles within a specific space. The higher the temperature, the faster the average kinetic energy is, the more energy something has. So if I put a really, really hot metal inside my orange juice, that means the thermal energy, the average kinetic energy, the temperature of this metal is going to go down, while the temperature of my orange juice, which is at normal temperature, is going to go up. This is because thermal energy always travels from the thing with higher temperature to the thing with lower temperature. So this means that my heated magnet has a higher kinetic energy. So molecules are moving fast while they're slower here. But guess what? When I put this heated thing here, my heated magnet in the orange juice, this gathers some kinetic energy while my magnet loses. This concludes our lesson on the laws of conservation of energy and matter, as well as energy transfer and transformation. These are vital concepts in order to understand our natural world. So practicing these concepts towards different situations is especially important so that we can understand and memorize how these work. If you have any questions, don't hesitate to reach me out or reach out to each other, and I'll see you in the next video.